If we're still doing algebra, we should be able to do just fine.
All right. Do you want me to type it out so you can see it?
Just verbalize it for me, and I'll write it out.
All right. Sounds good. So the first one is x minus 3 equals 2, and then in parentheses x minus 6.
Okay. What's our first step here?
So I went down it a little ways, but then I kind of got lost.
Okay.
So what
First,
I have so far,
first step is always try to remove your denominators and then your parentheses. Those are the things you really always want to get rid of.
Yeah, what I did first was that I distributed the 1.
Okay. The 2?
Like the invisible one, I guess you could say.
The 2, you mean?
The 2.
No, the only thing that can be distributed here is this 2. And multiply that, so we get this. You with me?
Uh-huh.
Okay, now what?
And then I subtracted 3 from both sides.
Okay, which gives you x equals 2x minus 15. Got to get x all by itself on one side.
Yeah.
So if we bring the 2x to the left by subtracting 2x from both sides, we'll have minus x equals minus 15. Divide both sides by minus 1, we get x equals 15.
Mm-hmm.
Now, let's go back to an earlier step because there's a better way to do this. At this point here, we have a choice. We can either gather our x's on the left side or the right side. And whichever one we choose, we're going to put all of our numbers on the other side, right?
Yeah.
Well, what if I take this x to the right side by subtracting 1x from both sides, and I bring this 12 to the left side by adding 12 to both sides? What do I get? I get x on the right, and I get 9 on the left.
Mm-hmm.
And that's the correct answer.
Yeah.
And notice there's no negative signs anywhere. In other words, I moved the x to the right so it would have a positive coefficient.
Yeah.
Did I lose you again? Because it says you, oh, that must have been the first Brianna, the one that got logged off, just left. Okay, so what mistake, I must have made a mistake the first time I did it, right? Because I got x equal 15. Well, it can't be both. So let's figure out how I made that mistake. I'm going to subtract 2x from both sides. So now I have minus x over there. And when I add 3, I have minus 9. I just made a mistake mathematically, which makes x equal 9. So I get the right answer regardless of which way I do it. But notice how much easier it is to make a mistake when you start bringing negative signs into it.
Yeah.
I did make a mistake the first time. I ended up with x equals 15 because it is so much easier to make mistakes when you have negative signs. Whereas if everything's positive, there's not as many opportunities to make mistakes. And there's nothing that says x has to end up on the left. Just as valid if I have 9 equals x as if I have x equal 9. So the decision that you always have to make at this point is whether to put all your variables on the left and all your numbers on the right, or vice versa. And the way you decide that is which is going to give you positive coefficients is the way I decide it usually. You can do it either way. There's no wrong way to do it. It's just you open up more room for mistakes if you do it the way you wanted to do it at the beginning.
Yeah.
All right, what else you got?
All right. So this one's a little bit longer, so I'm typing this next one.
You can't type it. I can't see what you're typing. Oh, unless
I know,
are you doing it in the chat?
yeah.
Oh, okay. Go ahead. I got to think it'd be easier to read it. And there is something learned by reading it. That you learn something when you verbalize it. I would actually rather you verbalize it, just so I make sure you understand how to verbalize these.
All right.
Try verbalizing. Try verbalizing. And I'll write it, and you tell me if I'm writing it wrong.
All right. So it's 5, and then in parentheses, x plus 4.
And then end parentheses.
Yeah, and then minus 3x plus 11.
Like this.
Uh-huh.
Or in parentheses.
Nope, that's good.
Okay.
And then equals 2. And in parentheses, 3x minus 5. And then minus 3x.
Okay. What's our first step?
Get rid of the parentheses.
Okay. So read the next line to me.
So it'll be 5x plus 20 minus 3x plus 11.
Okay. And then on the right side.
6x minus 10 minus 3x.
Okay. Now, before we
combine like
combine like terms, before we start moving stuff from one side to the other, the best thing to do is combine like terms on each side. So on the left side, what are our x's total?
2x.
And what are our numbers total?
31.
And on the right side, what are our x's total?
It'd be 3x minus 10.
Now we're going to gather all of our x's on one side, all of our numbers on another. Which way should we go?
We could add the 10 onto both sides.
In other words, we're going to put our numbers on the left, which means we're going to put our variables on the right. And we can do this in 2 steps, but I tend to do the next step at once. In other words, I'm going to move all the variables to one side and all the numbers to the other. And I like moving the 2x to the right because that's going to leave me with x with a positive coefficient. And I like moving the 10 to the left because that's going to leave me with positive coefficient. And in fact, I'm done. Okay? Now, watch what happens if I do it the other way around. If I move the 3x to the left and the 31 to the right, I end up with minus x on the left, minus 41 on the right. Now there's one more step. Now I got to divide both sides by -1 to get x equals 41. So doing it the wrong way actually adds one step to it. Okay?
Yeah.
So try to keep that in mind. Now, if one side is positive and the other is negative, then it doesn't really matter which way you go. Although I generally go whichever way gives me a positive coefficient in front of the variable. Always. Is the way I go. Okay? All right. Let's have you read another one. And this time I want you to say begin parentheses, end parentheses. And then there won't be any question about how I write it.
Okay, so this one doesn't have parentheses, but this one we're going to solve for y.
Okay.
And this one is pi equals 7x minus 2y.
Like that?
Yeah.
You did say pi on the left?
Yep.
Okay, if we're trying to solve for y, first of all, we're not going to be able to come up with a number for y because I have one equation and two variables. I have an x and a y. So the best thing I'm going to be able to do is solve y in terms of x. Okay?
Yeah.
And my final answer is something like this, where the x's are going to be over on the right side. I'm going to have y all by itself on the left. Okay? So the first thing to do is what? How do I get y on the left side?
Add it?
Yeah. So now I have 2y plus pi equals 7x. Now how do I get rid of the pi?
Subtract it?
So now I have 2y equals 7x minus pi. Now how do I get rid of the 2 that's in front of the y?
Not sure.
Divide. The way you solve equations is if I want to get down to y, I've got to piece by piece get rid of everything that's with it. Well, when I was at that stage, I had a pi being added to it, so I got to do the opposite. I got to subtract pi. And now when I get to this stage, I've got y being multiplied by 2, which means I've got to divide by 2. You always do the opposite of what is being done to that variable. Okay? Now, this answer is perfectly fine as an answer, or I could separate it into two fractions, 7/2 x minus pi over 2. You see what I'm doing when I separate it into two fractions?
Yeah.
Okay. You can do that as long as the denominator is a single thing. Okay? In other words, if I have a plus b over c, that's equal to a over c plus b over c. But if I have a over b plus c, I cannot do that. That is not equal to a over b plus a over c. See the difference?
Yeah.
So the only time you can break it into two fractions is if the bottom fraction is one term only. And it isn't necessarily right to break it into two fractions. There's nothing wrong with that as an answer. In other words, y equals 7x minus pi all divided by 2. That's fine for y. Or this, either one. What else you got?
Hold on, let me look. Okay, so -6, and then this is absolute value.
Okay, what goes inside the absolute value?
P plus 2 plus 3.
P plus 2 plus 3?
Yeah.
Like that? Okay.
And then end of that plus 15. And then plus 19p equals 0.
Okay.
So could we start by subtracting the 15?
Yeah, we can. But let's simplify it. Is this correct, what I've written in the absolute value?
Yeah.
So I can certainly do that, right? So now I have -6 times p plus 5 and plus 19p, and I'm going to make it all equal to -15. Okay. So I subtracted 15 from both sides and I added the 2 and the 3 together.
Uh-huh.
Now,
So we could add the 6 to both sides?
thinking, no, that negative 6 is a multiplier. So I could divide both sides by minus 6.
So we distribute it?
No, you can't distribute in absolute value. You can't take that minus 6 and put it inside. Hold on a minute. Let me think about this. Wow, where are you coming up with these problems? I've never seen a problem that had both absolute value of a variable and the variable in the problem. I got to think about this for a second. Maybe I can put that inside. Let's see. If P was minus 4, then I would have the absolute value of 1 times minus 6. That'd be minus 6. But if P was 4, I'd have the absolute value of 9, which is 9. Well, let's see if I can figure out how to do this. First of all, it's important to know what this means. If I say that, different problem. I'm just thinking out loud here. If I say absolute value of x equals 5, what does that mean? In fact, let's make it a little bit harder. Let's put absolute value of x plus 5 equals 15. Okay? What does that mean? How can I solve that equation right there?
Maybe that the x equals 10?
No, here's what you do. Is you take whatever's in the absolute value and you let it equal 15, and then there's a second equation that is an OR. With absolute values, you're always going to have two things. And the second part of the equation is the same thing in the middle, x plus 5, but this time it's going to equal minus 15. And notice that this gives you two solutions. One solution is x equal 10. The other solution is x equal minus 20. And notice that both work. If I put in x of 10, that's a proper equation. And if I put in an x of minus 20, it's a proper equation. So let's try that. Let's try, in fact, let's make a slightly simpler case of this just to see if it works when there's other variables around. In other words, if I said to you x plus 5 equals x minus 10, like that, which is kind of what we're looking at, well, what would that mean? That would mean x plus 5 equals x minus 10, or x plus 5 equals the negative of x minus 10. I'm going to be able to do this, so let's use this strategy on our problem. So what we want to do is we want to try to isolate that and have it equal something. And then I'm going to be able to use that system, okay? Well, the first thing I have to do is divide everything that we are looking at by minus 6. I got to divide this by minus 6. I got to divide this by minus 6. And I got to divide this by minus 6. Okay, that gets rid of the minus 6. Now what I have on the left side is P plus 5, the absolute value of that, plus turns minus because I've divided by minus 6. So minus 19/6 p, and I'll leave it like that instead of reducing it for the moment, equals 15/6. With me so far?
Yep.
Now let's move this to the other side.
Well, shouldn't we simplify first?
No, you can't simplify because I got a combination of absolute value and non-absolute value. Okay, so I'm going to move this to the other side by adding it, 19/6 p. Then I can erase it from this left side. And now I have it exactly as I want. In other words, I've got the absolute value isolated all by itself on one side. Well, so now that allows me to write that p plus 5 is equal to the right side, or p plus 5 is equal to the negative of the right side. And each of these is going to give me a different solution, but I expect two solutions when I have absolute value. Okay, well, on this side here, to solve that, I'm going to combine my p's on the right. So I'm going to subtract 1p from this, which is 6/6. So I'm still going to have 13/6 p. And I'm going to take the number over to the left. So I've got 30/6 minus 15/6 equals 15/6. You with me? Okay, the 6's go away, and I got p equals 15 divided by 13. That's 1p. Now I got to go to the second part. First of all, get rid of the parentheses. So I got p plus 5 equals minus 15/6 minus 19/6 p. Now I'm going to take this p on the right side and move it to the left because it'll be positive that way. So this is 6/6 p plus 19/6 p. I'm going to have 25/6 p over here. I'm going to take my 5 and move it to the right. Well, that's 30/6. So the right ends up with 45/6. And again, the 6's disappear, and p is going to equal minus 45 divided by 25. So I have two solutions for p, which I would expect. And if I go back to your original equation and plug in both of those solutions, that should work. It gave us such hard numbers that it would take our entire session to go back and prove that both work. Not quite our entire session. But if you want to check your answers, you should always go back to the original equation, plug in p, and see if this is a true statement. That's always the secret when you're solving equations, is once you come up with, especially if you solve and you get two different solutions, and absolute values tend to produce two solutions always. But what I haven't done very often is where you have the absolute value of the variable inside, and then you have that same variable without an absolute value. You cannot combine these. You cannot combine this 19p and this absolute value of p plus 5. You have to do it the way I did it. In other words, the standard thing, let's just go over it again. I want to make sure you get this. If I give you this equation, tell me how to solve that.
Uh,
Always start. The first part is exactly the same way I've written it without the absolute value. Like that. Okay?
Add 2 to both sides.
Let's write, first of all, the two equations we're going to be dealing with. And I put the or in the middle and the second equation on the right because I'm going to solve both of these equations vertically. So I want to write them horizontally, and that's the way your teacher will do it too. But the or part, never change what's in the middle of the absolute value, change the sign on the other side, like that. So that's what this means. It means that x minus 2 is equal to 10 or x minus 2 is equal to minus 10. Now, if I solve both equations, I get two solutions. One is 12. The other is minus 8. And you'll notice that here we can do the math real easy. If we plug in 12, we get, what's the absolute value of 12 minus 2 is 10. What's the absolute value of minus 8 minus 2? Well, that would put a minus 10 in the absolute value, and the absolute value of minus 10 is 10. So that works, and that works. And this is always the way you want to do absolute value problems. There's no other way I know to do them. Okay? The problem you gave me was a little more complicated because they had an x over here on the outside still. But it didn't really change anything. As long as you know what this means and how to write it as two separate equations, you'll be fine. Do you have another problem that has absolute value in it?
No, so I don't think we need to spend a lot more time on that.
Okay, what else you got?
3x minus 9 equals 9 minus x.
First step.
Add the 9 to both sides.
All right, here's the way I'd kind of like to see you think about this. Rather than doing it one step at a time, which generally I love, what you really want to do here is, are you going to end up with your variables on the left and the numbers on the right, or vice versa?
Oh, I want to end up with them on the left, so maybe add the single x to the 3x, make a 4x.
And add 9 at the same time. In other words, there's nothing that prevents you doing both of these at the same time. But the beauty of knowing which side I'm going to move it to is important, because now I know I'm going to have 4x equals 18. And x equals 18 divided by 4, which can be reduced to 9 divided by 2. Okay? So it's a useful first step to figure out in advance which side you're going to put your variables and which side you're going to put your numbers. In other words, I don't really want to move the 3x over to there because then I'll end up with minus 4x. And if I move this 9 to the left, I'll end up with minus 18. Again, I got all these negative signs that I don't really want.
Yeah.
You're going to get the same answer, but it just avoid negative signs if you can at all. Okay, what else you
got? This one's another solve for y.
Okay.
It's 6 equals 4x plus 9y.
Okay. The y is already on the right. So when we're done with this, we're going to end up something like this and something over here. Okay? So how do I whittle down what's on the right so that I'm left with only y? What do I have to do first?
Subtract the 4x to both sides?
Yes. 6 minus 4x. That leaves me with 9y now. Now I'm getting closer. Now what? How do I get rid of that 9? What is that 9 currently doing?
It's being a multiplier.
Okay, so what do I have to do?
You have to
What's the
Divided?
Yeah, what's the opposite of multiplication? Division. You're always doing the opposite of what it's doing. So I'm going to divide by 9, both sides, and my answer, now I got y all by itself. So I can list my answer as either this. Does your teacher tend to have a preference? Does she want 2 pieces, or just is one like that okay?
Just one.
Okay. I like this actually myself better, rather than breaking it up into 6/9 and minus 4/9 x, which I could do if I wanted to, but I don't need to.
Uh-huh.
Okay?
Uh-huh.
What else you got? Good
Um.
practice, these, for you. Really good practice. I don't know what that absolute value one was doing in there. That's like a problem for Algebra 3. Really is.
Mm-hmm. Maybe 5x plus, or no, just kidding. 5x minus 3 equals 7x minus 2.
Now, answer the question, which side are you going to have the variables on? Which side are you going to have the numbers on?
I'm going to have the variables on the other side.
The right.
Or on the left.
Say the right side, because I don't know what the other side means.
Variables on the right side.
Okay.
And then numbers on
the left. Okay, so let's do both steps in one. What's left on the left?
So you'd have to first
add 2 to both sides. What's that?
Oh yeah, add 2 to both sides.
Okay, what's that give you on the left? What's minus 3 plus 2?
That'd be minus 1.
Okay. And then when I move the 5x over, how many x's do I have?
You'd have, it's like, I don't know.
Just subtract 5x from both sides.
So then 2x?
Yeah. In other words, in order to move something that is currently an adder, that really is being added to the left side of the equation. Even though there's no plus sign in front, it's being added. I could write this like this. Same thing. Okay, now there is a plus sign in front, and you can see it's being added. So in order to get rid of it, I got to subtract it. Okay, now notice that one of my sides has positive coefficient, the other side has negative. That's going to happen no matter which way I decided to move my variables. One side's going to have a positive, the other's going to have a negative. So sometimes you just can't avoid it. What's the last step?
It would be -1 divided by 2.
You got it. Okay, let's do more. More of these you can do and do successfully. The more confident you're going to be, and you'll know how to do them forever.
Yeah, okay, so the next ones are kind of a little bit more difficult to verbalize.
Try it anyway.
Well, it's like graphs and stuff like that.
Oh, that's impossible to verbalize, but it's going to be impossible for you to type in also. Now, let's see. Do you have any more that you can verbalize? If you want, you can take a picture of the graph and send it to my email address.
Won't that take too long?
Probably not. Takes you about 30 seconds to take a picture. It'll take you another 30 seconds to send it.
All right. So what's your email, David?
David Cowan.
All right, I got it. It's saved.
Okay, I thought you had it saved in there. Once you get the first 2 letters of it. Tell me after you've sent it.
I sent it.
Okay. Is there just one attachment?
Yeah.
You have an iPhone?
Yeah, it's in the middle of sending.
Did you send it as a large image?
I just sent it as a normal image.
Okay, with the iPhone, it's going to ask you whether you want to send it as a large image or a small image.
No, it didn't ask me.
And ask you, well, pull up your picture that you took from your gallery and share it, is the way to do this. And then choose Gmail and type out my Gmail address. I'm not sure how you sent it, but it didn't get sent.
Well, it's not completely sent. It's in the middle of sending still.
Is it just one picture on that email?
Yes.
Okay, because the more pictures you add, the longer it takes to send.
Mm-hmm.
It appears to be having problems sending.
Okay.
With an attached, you may not be sending that picture properly. After you take the picture, how do you send it with an iPhone? I'm not sure how to do it with an iPhone. I know how to do it with a Samsung phone.
I just went through text message and I put your email address in.
That's probably not the way to do it. Do you have a gallery that stores
Yep.
all your pictures? Pull up the gallery.
Uh-huh.
Find the picture you just took.
Uh-huh.
Click on it. In other words, checkbox it.
Uh-huh.
Now share.
I do not see a share option, but we are
You send it.
almost.
In other words, how can you send that picture to an email address? That's what you need to do. And send it to an email address. Not as a text. There you go. It came through. I guess the first way you did it probably was fine.
Uh-huh.
Okay, hold on. Let me download that, and then I can rotate it. Looks like you probably sent this as a small image. Notice how bad the resolution is?
Uh-huh.
That's the difference between a small image and a large image. I can still read it. We can still do the problem. But if you send it as a large image, this would be crystal clear. It's just a small image. It doesn't.
I don't have the option, so I
You may
can't.
only get the option if you try doing it the way I suggested, which is to pull the photo up from the gallery.
Well, I don't have that option.
Okay. All right. Well, we'll figure that out next time, I guess, how to get clearer pictures. In the meantime, let's tackle this one. The line has a slope of 2/3 and a y-intercept of 1.
Uh-huh.
Well, should we graph it first or should we write the equation out? What's the standard equation of a line? Y equals what?
I don't know.
Mx plus b.
Yeah.
If you don't know that, memorize it. You're going to need that for the next 3 years, at least. It's the most common standard format of a straight line, okay? M is the slope, and B is the y-intercept.
Mm-hmm.
Well, they gave you both of them. So what's the equation of this line? Slope is 2/3, or is that minus 2/3? What's that? What's line A say? Is it minus 2/3 or 2/3? I can't quite read it. Brianna, you still there? Did we lose you again? That's okay. We'd only have a couple minutes left anyway, so let's not wait and have you reboot and do any of that. Let's talk about this problem, okay?
Well, I'm on.
Oh, you're on back on. Boy, it doesn't take long for you to get back on, does it?
Yeah.
That's amazing. All right. Let me hang up. Okay, can you hear me?
Yep.
Okay. So if y equals mx plus b, and m is the slope and b is the y-intercept, they give us the slope and the y-intercept. So
Yeah.
what's the equation of line A?
Y
Is that a minus
equals
2/3?
what?
Is that a minus 2/3 slope?
Yeah, so it'd be y equals negative 2/3 plus 1.
That's the equation of that line. Very, very simple. If you know the slope and you know the y-intercept, then it's really easy to come up with the equation. Now, to graph it, it's also pretty easy. Where do you start with your graph?
On the y-intercept?
Yeah, at 1. We know that point is on the curve. Now, we need one more point. Well, I know the slope. How do I get another point?
You do the, okay, so then you go.
Remember, it's rise over run. So I got to
Yeah.
up 2 over 3.
Yeah, but since it's
Which
negative,
way?
you go
Yeah.
to the left 2 and then down 3, I believe.
Now, that would give you a positive slope. If I go left 2 and down 3, there's my other point. Connect those 2 points, that's a positive slope. So that's the thing. You can do this in a number of ways, but make sure you have the sign right on your slope. It's rise over run, so I got to go up 2, left 3. Now if I connect those 2 points, that's a negative slope. That's the way to do it. Notice I also could have gone down 2 and right 3 to come up with that as a second point. Same line, same negative slope. So you can go up and over or down and over. Just make sure your over produces the right sign slope. That's the key. Okay? So let's look at the second one here. I'm going to leave that there.
Do you have another lesson?
I do at 7:30. I can go till like 7:15 and give you a full hour, or 7:20, whatever it was.
Okay.
Does that work?
Yeah, that's perfect.
Okay, good.
Thank you.
Line B, any line that is perpendicular to line A. Well, what do we get for line A? We got y equals minus 2/3 x plus 1. Perpendicular means what about, oh, no. Perpendicular means what about slope? If my new line is perpendicular to my first line, what is its slope? There's a relationship between slopes between perpendicular lines. The slope of the perpendicular line is the negative reciprocal of the first slope. What's the negative reciprocal of that number?
3, negative 2.
The negative turns it positive. The reciprocal makes it 3/2. So that's what it is. That's the negative reciprocal of minus 2/3. With me? The negative reciprocal of minus 4 is positive 1/4. The negative reciprocal of 3/5 is negative 5/3. Get what we're doing?
Yep.
You always
Yep.
have to do two things when you're finding perpendicular slopes, not one. Just always remember you got to do two things. You got to flip the fraction and you got to change the sign. So it's always two things. Okay?
Yeah.
And if that's all they want is a perpendicular line, then that's the answer. In other words, they didn't specify anything else other than this line had to be perpendicular to the first line. Well, it is by definition. My first line had a slope of minus 2/3. I don't care what the y-intercept was, but the fact that this line has the negative reciprocal of the first one means that this line is perpendicular to this line. And to tell you the truth, it could be plus 2, it could be plus 20, it could be plus 200. It doesn't matter. It doesn't matter what the y-intercept is. The only thing we care about for perpendicularness is negative reciprocal slope. Okay? So let's look at C. What does C says? The line has a y-intercept of 4, but a more steeply decreasing slope than the line A. A more steep. So let's talk about slopes first of all. Which slope is steeper, A or B?
B is.
Okay.
No, A is.
No, B is. Steeper means more vertical.
Oh, I see.
Okay. And in fact, the slope on A is less than 1. It might be like 1/2. And the slope on B might be greater than 1. Remember, a slope of 1 is the 45-degree angle. So anything steeper than that is a slope greater than 1. Anything flatter than that is a slope less between 0 and 1. Okay? And the same thing applies to negative slopes. In other words, if I want to draw these lines about a negative slope, well, now tell me which is steeper. I've got negative slopes. This is A, this is B. Which is steeper?
A?
Correct, because it's more vertical. But it's still going to have a negative number. So this slope might be minus 3. This slope might be minus 1/2. Kind of get the picture? Slopes that are greater than 1 are steeper. They're more vertical than a 45-degree line. Slopes that are between 0 and 1, like 1/2, are flatter. They're closer to a horizontal line. Okay? So, their question is, this was our first line, A, and they want another equation that has a more steeply decreasing slope. Well, that's a number less than 1, right? 2/3? Ignore the negative sign for a moment. Okay? So all I got to do to be steeper is make that number greater than 1. So how about I'll make it a 2. I still want the negative sign because they said it's still a decreasing slope. So if I make it minus 2x with a intercept of 4, there you go. This line is, let's go back and plot line A. Line A was like this, right? Going through 1.
Yeah.
And it has a slope that's a little flatter than normal, right? It's not very steep. That's because 2/3 is less than 1.
Yeah.
Now if I look at my second line, the answer to C, well, the only thing it has to do is go through 4. They said it was still negative, but more steeply decreasing, which basically means that there is a steeply decreasing, it's still a decreasing slope, decreasing meaning negative, but it's steeper than the first one.
Uh-huh.
It's a number greater than 1. So it's all
Yeah.
I have to do to get a greater decreasing slope is to increase the size of that number. I could have even made it just 1, and it would still have been decreasing and steeper than the first one.
Yeah.
All right. Now, is that the only thing on this page?
Uh-huh.
Want to try sending me another page real quick?
That was like the last page, I believe.
Okay. Well, we can stop here if you want.
All right, that sounds good, because, yeah, that's all I needed to work on tonight.
Okay. Sounds good. Let's see if there's any other last tidbits I can give you. Let's just check your knowledge of slopes. I'm going to draw a bunch of lines. I want you to tell me whether they're positive or negative slope, okay?
Uh-huh.
I can figure out how to do it here. Okay. Black. Positive or negative?
That is positive.
Correct. The red.
That's negative.
The green.
That's positive.
The blue.
That is negative, or positive.
It's actually 0. I meant to draw that as a horizontal line. Horizontal lines always have slopes that are 0. Okay?
All right.
Vertical lines always have slopes that are basically infinity, but they call them undefined.
Mm-hmm.
Okay? So in other words, if you know vertical lines are undefined slopes and you know horizontal lines are 0 slopes, and you knew which ones were positive and negative, you're good to go. I mean, there's nothing more that you need to understand about slopes. It doesn't matter which side of the x-axis it's on. Notice this blue one at the bottom I drew down here. I could have drawn it up there. It's still a 0 slope.
Mm-hmm.
Okay. Okay, I'm going to do one last thing here. Yeah, no, I don't need to do one last thing. I can do it right now. Okay, I'm going to put a bunch of slopes, and I want you to tell me which lines they refer to. Okay?
Mm-hmm.
So, which slope is most likely to be plus 20? Which color line? What's the steepest positive slope? Which color line?
Black?
No, that's flatter than the green, is it not? Isn't the green more vertical?
Oh, it is.
Steepness has to do with how vertical it is. Okay?
Okay.
So the green line, that easily could be a slope of 20. That's pretty vertical, right?
Mm-hmm.
Okay, now I'm going to put another slope on there. Which one is that?
The straight up and down blue one?
No, remember straight up and downs are undefined. And remember what undefined means. Undefined means infinitely large. In other words, if I take this green line and I keep making it straighter and straighter, more vertical, it gets bigger and bigger and bigger until when it's absolutely vertical, it's infinity. It's as large a number as you can possibly get. Okay? So the one that's 1 is this black line here. It's about a 45-degree line, right?
Mm-hmm.
That's a slope of 1. In other words, if I got to go up 1 and to the right 1, that makes a 45-degree line. That's 45 degrees there. Or at least I was trying to draw it that way. Okay.
Uh-huh.
Now, which slope is minus 20?
The red.
Yeah, the red is very steep and it's negative. So it's going to be a negative slope, but a steep slope, a slope greater than, the absolute value of it will be greater than 1. Okay?
Uh-huh.
And which slope is 0?
The straight one.
A horizontal straight one. They're all straight, but the horizontal line, the blue horizontal line, either one of them has a slope. This one has a slope of 0, and this one has a slope of 0. This vertical line, that's a slope of undefined. That's what you always want to put as the answer also, is undefined. Okay? All right. That's a pretty good session. I think we covered quite a bit in that session. So you're good to go, I believe. Only thing I need from you is your mom's email address. Let me see. Do you know it?
Yeah.
Can you give it to me?
Uh-huh.
What is it?
Do you want me to type it?
Yeah. That's the best thing for this, for sure. Avoids misspellings. Okay. I believe I do have this one, actually. I'm almost positive I do. Kendra Gregory 41, 914 at Gmail. Okay, I do have that. And I will send the invoices to that email address. Okay?
What?
I will send the invoice for your sessions to that email address.
Okay.
Okay? Now let's see. You had like an $8 credit coming into today. Today's session is 32. So your mom's going to owe like 24. Okay? And I'll go ahead and send an invoice for that. Although she can wait for the second session if she wants to make a payment. I don't know how she's going to pay. I don't know if she's opened a PayPal account yet or whether she's going to send a check. Either one is fine. She can pay either way. And on the invoice that I'll send her, we'll have my address if she wants to send a check to me.
All right.
But like I said, she doesn't need to send a check for 24. But once it gets up over 50, I would like her to pay, however she's going to pay. Okay? All right, Brianna, I will talk to you next time.
All right, David.
Good to go?
Yep.
Okay. Talk to you later. Bye-bye.
Bye.